Greetings. Oh, I'm so happy to see you here. Welcome to the Innovations in Healthy Aging lecture series. We are delighted tonight to have the speaker of honor, Roberta Diaz-Britton, who will be talking about vibrant brains that last a lifetime, a topic that's critically important for each of us. So I'm very delighted to have her here. I want to take just a minute here. Nearly a year ago tomorrow, the University of Arizona community suffered a profound loss when the life of Dr. Thomas Meixner was cut short by an act of violence. Dr. Meixner served as professor and head of the Department of Hydrology and Atmospheric Sciences. He was a great colleague and mentor and beloved by many, and we want to take a moment of silence to remember him. Thank you. So I'm Kathy Insel. I'm the director of the Innovations in Healthy Aging Strategic Initiative, and I want to thank you for joining us. I want to give you a very brief description of our initiative because I know we want to get right to the talk. Some fast facts. By 2030, 1 in 6 people in the world will be age 60 and over. Between 2015 and 2050, the proportion of the world's population over 60 will nearly double from 12 to 22%. And I want to point out an interesting fact to me, that the number of workers 65 and older has increased by 117% in a span of 20 years, according to the U.S. Bureau of Labor Statistics. The goals for the Innovations in Healthy Aging Initiative were to create an age-friendly university that welcomes older adults as part of our community, and that's why I'm so glad to see you in the audience today. You are part of our community, and the university is part of the community in general. We also wanted to partner with developers of senior living communities and aging industry experts. We wanted to expand our capacity in research and discovery focused on aging, and we want to increase the workforce to meet both the opportunities and challenges of our aging population. I'm very grateful for the leadership, the co-leadership of both Dr. Mindy Fain and Dr. Esther Sternberg. Dr. Sternberg is sitting in the front here. If you wouldn't mind, just stand up for a second so that people can see who you are. Thank you so much for being here. I can say that without the persistence and consistent efforts of these amazing women, the initiative would not have launched and been sustained. I also want to thank Anissa Westcott because she is part of this leadership team for sure. You should stand too, because what I realized is that people online can't see you. I also want to acknowledge Dr. Michael Dake, SVP of the University of Arizona Health Sciences, the co-creator of the initiative at the beginning, and for his continuous support. And I want to thank the Office of Strategic Initiatives, and in particular, Jane Hunter, Vice President of Strategic Initiatives. So Innovations in Healthy Aging, I want to give you a heads up that we have some things going on. We have Aging in the Arts Poetry Circle. I don't know if you've been over there, but it occurs once a month. It's run by the docents. We are very lucky to participate with them. I think I started from the bottom of the slide, so if you're losing me, it's a correct assumption that you're losing me. We also have this program on awe walking, which is mindfulness and collage coming up next. That will be on October, or you need to register by October 13th. Please join us for these. We've had them all over the city in different locations. From the reports I've gotten from people, they've been a lot of fun. So I really encourage you to check that out. These are all on our website. It's https://healthyaging.arizona.edu. So do check out the website too, because you'll see other events there. Now, I am so privileged. It is really an honor to be able to introduce Dr. Roberta Diaz-Britton. She leads the Center for Innovations in Brain Science at the University of Arizona, a university research biotech ecosystem devoted to developing therapeutics for Alzheimer's, Parkinson's, multiple sclerosis, and ALS. She is a Regents Professor, no small feat, of pharmacology, neuroscience, and neurology at the University of Arizona College of Medicine. Her neuroscience research spans discovery, translational, and clinical science. Authoring over 250 scientific publications, holds multiple patents, and founded 2 biotech startups, most recently New Therapeutics. Dr. Britton is an internationally recognized expert in Alzheimer's, whose discoveries have led to innovative therapeutics to prevent, delay, and treat the disease. She is currently conducting 3 National Institutes on Aging Phase 2 clinical trials, no small feat, that these trials are oriented toward preventing, delaying, or treating the disease. She is currently conducting also a trial that includes Regen, is that it? Regen Brain, to regenerate Alzheimer's brains. Dr. Britton serves on the NIH Directors Advisory Committee Working Group on Diversity, the NIA, so that's National Institute on Aging, Scientific Advisory Board, and the Alzheimer's Drug Discovery Foundation Board of Governors. Her honors include Scientist of the Year from the Alzheimer's Drug Discovery Foundation, Goods Prize, Arizona Bio Researcher of the Year, and the U.S. Presidential Citizens Medal for STEM education. Thank you, Dr. Britton. Welcome.
Well, thank you, Dr. Insel, for this, your lovely introduction, and I'm delighted to have the opportunity to share some of the research that we've been conducting in the Center for Innovation in Brain Science and in my laboratory that really focuses on how to change the trajectory of aging. Terrific, thank you. And the goal obviously is to sustain vibrant brains that last a lifetime. Okay. There we go. All right. Maybe I just should, yeah, I'll just tap it and then that, yeah, thank you. So these are my disclosures and our funders that fund our research. And as Dr. Insel mentioned, we have a biotech company, New Therapeutics, formed here at the University of Arizona. So, many of you will recognize, okay, here we go. Let's see if this works, yeah. Recognize this photo. Yeah, I see people do. And many of you will recognize this as a photograph taken at Woodstock in the 1960s. And I do have to point out that there's a young woman here. I guess I gotta get my laser going here. There's a young woman in that photo. Okay, so, you know, when we did this for the, there it is. Right here. And that is my doppelganger. And that's what I looked like in the 1960s. I was not at Woodstock. My husband was, though, and I didn't know him then. But I was shocked to see my doppelganger there. So for many of you, this is kind of the time of our lives, and we now know that Alzheimer's disease will affect 11% of people over the age of 65. So basically 1 in 10 persons, right? And when we look a little deeper into those who are at greater risk, we find out that women are at greater risk of developing Alzheimer's disease. 2/3 of all persons with Alzheimer's disease are women. And we typically, there's a thought that, well, it's just because women live longer than men. And it's true, we do, by about 4.5 years. And that's not sufficient time to explain a disease that is 20 years in the making. And so we have been focused on understanding Alzheimer's disease during the aging process, and what we've learned about why the female brain is at greater risk, we've also learned about the male brain. So age is the greatest risk factor for Alzheimer's disease, and the National Institute on Aging has a goal to prevent and effectively treat Alzheimer's disease by 2025. What I would suggest is that it's unlikely that we'll be able to effectively treat Alzheimer's disease in just 2 years, but I think we have very compelling evidence that we have the potential to prevent Alzheimer's disease. So let's think about aging. And typically what we think about, and we think about this, is it's a linear process. We start out alive and we end up dead. That isn't the way biology ages, and it's not the way the brain ages. The brain ages in a series of transitions. And those transitions happen over time, right? And so part of what we have is a transition that starts, and then there's a stable period, and then another event happens, and then there's a drop to the next transition, and then another drop to the next transition. And the challenge really is 2 things. One is, how do we prevent these transitions of aging? The other is the idea that you can start out here with severe disease and have a single therapeutic that will then reverse that disease. And it's far more complex than any single one medication or therapeutic. And when we look at this aging transition, oftentimes those events that create this change in the aging trajectory are stressful, right? The death of a loved one, financial loss, and other factors can then precipitate this decline. And what we often hear is, Dad was fine, Mom was fine until, right? And then we noticed, right? And that's this transition state, which I'll talk more about now. So part of the aging process is that these transition states can span years, and those can be the prodromal, the early stages of disease like Alzheimer's. So when we think about transition states, how many of you have gone through puberty? And it didn't happen overnight, right? It happens over the course of time. And a couple of things are important, right? So you go into this transition state, and it's a remodeling project on the brain, right? We think about reproduction from the neck down, but in fact, reproduction is really a function from the neck up in the brain. And this whole process of puberty means that we do this remodeling, we do this remodel on an existing structure, so to enable reproduction. Now, why is that important? It's because this whole remodeling project, this transition state from not being reproductively capable to being reproductively capable, actually has to happen in sequence, right? And everything has to work well. And what we find is that in puberty is a risk factor for depressive illness in females and ALS in males, and multiple sclerosis in both females and males, none of which has anything to do with reproduction, but everything to do with the brain. So let's think about these transition states. So transitions, so this is where within this well-controlled normal condition, and now we move out into this transition state. So we're moving from a very well-controlled system to a less well-controlled system, and we're at the edge of normal, right? We're at the edge of normal. And now we can move from at the edge of normal to now a disease state. And obviously, the potential to intervene successfully during these transition states is key, and the earlier the better. So let's think about Alzheimer's disease, which affects the aging population primarily. And here we are at healthy aging, right? Everything is well controlled. And then there is a transition to mild cognitive impairment. And then ultimately to another transition, which is close by, which is late onset Alzheimer's disease, typically after the age of 65, and then terminal AD, right? But what this tells us, and this is work done with Dr. Ray Cheng in our center, is that there's a big shift, there's a big distance between healthy and that first stage of Alzheimer's disease. And we have lots of opportunity to intervene. Now, once that transition has happened, there's a shorter path to actually this late onset Alzheimer's disease. And then there's a longer path to essentially death with Alzheimer's disease. So at each of these components, we have possibilities for intervention. So we've been very interested in how can we identify two things. One, the on-ramps. So how many of you have ever driven in LA? Okay. So you know, how many of you have been on the 405, the 110? Okay. So you know there are a lot of on-ramps to the 405. Now imagine there are no off-ramps, right? And that's where we are in Alzheimer's disease. There's a lot of on-ramps to developing Alzheimer's disease, and at this point, no off-ramps. But we're tackling that problem. So we're quite interested in these on-ramp risk factors, and how can we mitigate those? How can we mitigate those on-ramps? And ultimately, can we develop off-ramps? Okay, so can we identify the on-ramps to Alzheimer's disease? And this is work that we've done in the center with Dr. Francesca Vitali and others in the group, and a number of folks from my laboratory, which I'll mention as we go. So we looked at the risk factors, and can we identify the on-ramps? And the answer is yes. This is, again, work with Dr. Francesca Vitali and Greg Brannigan. And yeah, there are actually 364 on-ramps to Alzheimer's disease. and that serve as risk factors. Now, not everyone who develops a risk factor is going to develop Alzheimer's disease. And so part of the question that we've been asking is, yes, we can identify those on-ramps, and can we target those on-ramps to reduce risk? And so this is data from one of our studies conducted with, in collaboration with Dr. Kathy Rogers and Georgina Torrendal in my group. And what we find is type 2 diabetes is a risk factor for Alzheimer's disease, and we asked, do these therapies that treat type 2 diabetes, do they actually impact the risk of developing Alzheimer's disease? And what you see here in the middle is 0, right? So that's essentially no disease or disease presence. But type 2 diabetes therapies, on the whole, are fairly successful or fairly effective in reducing the risk of Alzheimer's, for all neurodegenerative disease, Alzheimer's, non-Alzheimer's dementia, Parkinson's, and ALS. And here's multiple sclerosis. And that was quite surprising to us. And it turns out that these people who are developing multiple sclerosis are between the ages of 45 and older, right? So there's something about that aging process. What about hypercholesterolemia? That people typically are prescribed statins. And statins actually are quite effective in reducing the risk of Alzheimer's, a non-Alzheimer's dementia, multiple sclerosis, Parkinson's, and ALS. So statins are actually quite effective in reducing the risk. And I can regale you later with why that is, right? And we also replicated the effect of the type 2 diabetes therapies in data from the Veterans Affairs, and we see that, and in this case, we were looking at metformin as the control group, and essentially what these data told us is metformin being the first intervention for pre-diabetes and type 2 diabetes, that in fact, metformin is your best shot, right? And then adding other type 2 diabetes drugs onto metformin are beneficial, but minimally so, right? That it's really metformin that is having a terrific impact. Okay, so what about other interventions? So an area that we've been quite interested in is menopausal hormone therapies, because what we found is that Alzheimer's disease in women can actually start at menopause, during this menopausal transition, which is why I had you think about transition states. And the menopausal transition is another transition state for women. Now, it turns out, again, here's zero risk. And what we find is that for each of these, menopausal hormone therapy reduces the risk of developing multiple age-associated neurodegenerative diseases. And menopausal hormone therapy is quite controversial. And the controversy is really about, when did women start menopausal hormone therapy? And the data show that when women start menopausal hormone therapy for menopausal symptoms, that's in midlife, there is a reduced risk. If women wait until they're 65 and 70 and don't have menopausal hormone therapy or don't have menopausal symptoms, they actually have no benefit of hormone therapy, and with certain formulations, a modest increased risk. So since we'd found that estrogen hormone therapy can reduce the risk dramatically of these age-associated neurodegenerative diseases by about 50%, we asked, what about breast cancer therapies, right? And this was work of Greg Brannigan in my group, and what he found is that, surprisingly, women who were on breast cancer therapies typically had a reduced risk. Not as great as estrogen alone, but these molecules are acting actually as estrogen antagonists in the breast, but activating estrogen receptors in the brain, which we were very excited about. So guys, I haven't forgotten about you. So what about testosterone, right? And testosterone, typically for andropausal symptoms, reduces the risk of all age-associated neurodegenerative diseases, Alzheimer's, non-Alzheimer's dementia, and other forms of dementia. But look what happens now for both Parkinson's and ALS. It actually increases the risk, right, for those two diseases that are preferentially affect men more than women. So we also looked at these anti-androgen therapies that men are receiving for prostate cancer. And what these data show you is that there's a lot of variability. What I will tell you is that do your very best not to develop prostate cancer, because the drugs that are used to treat prostate cancer actually have an increased risk of developing age-associated neurodegenerative diseases. So it's on you not to develop prostate cancer. So the question is can targeting that on-ramp risk factor for Alzheimer's disease reduce risk? The answer is yes, it can. Are there sex differences? Are there differences between men and women in how they respond to these therapies? And the answer is not really, no. Women and men respond very well and almost equally to type 2 diabetes medications. And again, look here, that in older individuals, type 2 diabetes medications in both men and women increase the risk for multiple sclerosis. But in statins, it's women and men are responding pretty equally, except there is a bit of difference in the women. Men are better responders to statins than women. So, are there sex differences? Yes and no, right? Statins overall are beneficial, and they're more beneficial in men than women. So are all these therapies equal? Are all of these therapies acting equally? And the answer is, for statins, pretty much, right? Rovastatin and pitavastatin probably have the better profile. You know, my favorite is atorvastatin, which is Lipitor. And why I like Lipitor is that it was the first statin developed. And when you get to simvastatin and pravastatin, for example, they're less effective than atorvastatin. And that's because they're much more selective for targeting this enzyme that's important for cholesterol synthesis, HMG-CoA. They're very, very selective. Now, when you look at atorvastatin down here, it's like, yes, it affects that enzyme, but it does a whole lot of other things. And it turns out that those other things, for example, reduce inflammation in the brain. So my favorite is the oldest drug, oldest statin there is. And that's typically the one that is provided when folks receive statin therapy as generics. Okay, what about type 2 diabetes therapies? And the answer is yes. The type 2 diabetes therapies are pretty equal in their efficacy. Now, we haven't had the opportunity to look at Ozempic and those new type 2 diabetes drugs because they just haven't been around enough. So it'll be very interesting to see how that compares to these more traditional type 2 diabetes therapies. So what Greg and Francesca did is look at, well, how confident can we be of these therapies? And the bottom line is pretty confident, right? That yes, they do reduce risk, and this reduction in risk is consistently seen through the scientific literature and the clinical literature. So it's not just a one-off. It is actually reproducible science, which is very exciting. So are all drug classes for the risk factors created equal? No, but most of them are, right? Particularly for type 2 diabetes. So then, but let's think about this, right? So there are individuals, so if you have a 50% reduction in risk with a therapy, that means some people are actually going on and developing Alzheimer's disease despite the fact that they're on a type 2 diabetes drug or a statin, right? They're going on and developing the drug. And so we asked, hold on, what constitutes those individuals? What does a responder to those therapies look like? What does a non-responder look like? And when we looked at those data, what we found is it's two things. One is what's called the comorbidities. So lots of people who have type 2 diabetes also have dyslipidemia, and then also have a cardiovascular component, right? So these are comorbidities. We looked at, for example, type 2 diabetes, and then also looked at, well, you have type 2 diabetes, do you have anything else? And when we looked at what constituted the comorbidities among these non-responders, there were about 14% have osteoarthritis, 5% are obese, 14% have about respiratory disorders, but 68% have cardiovascular disease, right? Now, let's stop and think about the cardiovascular system. Now, I'm not going to ask for a show of hands about who exercises. However, and I always give this lecture to myself, the cardiovascular system is your fuel delivery system, right? Think about when you're driving up to Phoenix and you get to that point on the 10 west where it narrows right before you get to Phoenix. Everybody's going 80, 90 miles an hour, and then all of a sudden you have to get down to 2 lanes, right? That's a classic example of what happens in the vascular system. If the vascular system is not open and essentially free-flowing blood throughout the body, it begins to narrow. And then you begin to have pile up, right? And the same is true in the vascular system. The vascular system is the nutrient delivery system for the entire body. Now, let's think about the brain a little bit. So the brain is a glucose-dependent organ, right? It primarily uses glucose as its fuel to generate energy. So the brain is one of the most energetically demanding organs of the body. From here down, we're a Prius. From here up, we're a Hummer. The brain weighs 2% of body weight and consumes 20 to 25% of the oxygen and the glucose. And so anything that disrupts either access to those nutrients or the utilization of those nutrients, like type 2 diabetes, actually can impair brain function first because of its dependency on glucose as its primary fuel. Now, then we ask the question, all right, so here are all these folks that are non-responders to these therapies. Are they male or female? And it turns out that 2/3 of the non-responders are female, right? So it turns out that women, again, when we look at the risk for developing Alzheimer's disease, 2/3 of all persons with Alzheimer's disease are women, and now we look at those that respond to therapies that reduce the risk, and if a woman has cardiovascular disease, she is more likely to be a non-responder, right? So, and that's critical for, obviously, preventing diseases in aged women, particularly Alzheimer's disease. So what defines a responder and non-responder? Cardiovascular disease, whether you're female or male, but also particularly if you're female. So now we ask the question, can on-ramp preventive strategies function as therapeutic off-ramps? So one of the things that is, in current state of the field is it doesn't matter how you develop Alzheimer's disease, the treatment is the same. And the treatment now is primarily to remove beta amyloid plaques from the brain. How many of you have heard of beta amyloid plaques, right? And so the primary treatment now is to go in and remove those plaques. So that's a good thing. It can actually slow the rate of decline. It does not reverse the disease. It slows the rate of decline. Now, one of the things that beta amyloid antibodies do is they remove the plaque and in certain instances reduce the generation of plaques. It's like taking out the trash, right? Taking out the trash is a good thing. It doesn't do anything to what's generating the trash, right? And that's the same thing with these antibodies. It takes out some of the plaques, to be sure, they're very effective in that. What they don't do is go upstream and ask, well, why are these plaques being generated, and what can I do about that? So we have actually thought about, hold on, if there's so many ways to develop Alzheimer's disease, so many on-ramps, can that actually tell us about how to build the off-ramp, right? And part of that is one size is not going to fit all. If someone developed Alzheimer's disease through dyslipidemia, maybe that is telling us about how we should begin to treat those individuals. And the same with type 2 diabetes. And what happens if you have comorbidities, right? So we're just starting this work, but we're very excited about the potential of combination therapies that now build the off-ramp, but also build this precision medicine approach to Alzheimer's. So the road ahead, what's the road ahead? Can we identify the on-ramps? Yes, we can. Can we target those on-ramp Alzheimer's risk factors? Yes, we can. Are there sex differences on risk reduction? Largely no. I mean, women and men benefit almost equally. Are all drugs for the risk factors created equal? No. Some are better than others. And what defines responders versus non-responders? So no, not everyone is a responder. And that typically it's cardiovascular disease, which is defining a non-responder. So I ran over here to give this talk while working all day on the proposal to actually fund the research that I just described to you about, can we learn about how we can effectively treat Alzheimer's disease if we know how the person actually developed the disease. So I want to go back to this concept of transition states to give you some sense of where we're going in our clinical trials that Dr. Insel mentioned. So again, we're looking at these transition states, particularly here, right? And what we see with the menopause is that some women are very well controlled in terms of their glucose metabolism and their other metabolic factors. And then some actually move into this transition state, right? And others now move actually into Alzheimer's disease, right? So we have focused a lot on this transition state in the female with a focus on prevention and treatment. So we're quite enthusiastic about preventing that transition to Alzheimer's disease in those at greater risk, and these are postmenopausal women. So let's, now for the guys in the room, just think this is andropause, but this is what we've learned from the female. So why are women at greater risk for developing Alzheimer's disease? Is it because they live about 4 to 5 years longer than men. And so when we look at the average age of Alzheimer's disease, it's 70 to 75. We know that the disease is 20 years in the making. And very simple math, what we find is that in those right before that 20-year prodromal phase, we run into the age of menopause in their mid-50s. And so what our work has shown over many, many years is that women are at greater risk for developing Alzheimer's disease, not because they live longer, but because they can start the disease earlier. So if estrogen is beneficial for the brain, why do 80% of women elect not to receive hormone therapy for menopausal symptoms? Because we know that menopausal hormone therapy can significantly reduce the risk of developing Alzheimer's disease. And the reason is, it's the fear of breast cancer. So part of what we had to do, if we were interested in promoting brain health, we had to listen to women and also promote breast health. And so the challenge was, how do we do that? How do we promote estrogen action in the brain and not in the breast? And the answer to that question came through painstaking work that I can regale you with later, that really looked at, first of all, why are women electing not to receive hormone therapy, the fear of breast cancer, and where are they going for that alternative? And where they're going is to an open access, either a drugstore or a natural product store, and they're purchasing over-the-counter soy products that advertise that they are effective. They don't advertise whether they're safe, and in many instances, they're not effective and they're not safe. So we developed a formulation of 3 estrogen-like molecules from plants that promote estrogen action in the brain, but not in the breast. And in fact, in the breast, these molecules promote mechanisms that reduce breast tissue proliferation, whether that's normal breast tissue or cancerous breast tissue, and it also reduces the migration of cancer cells from the breast. So we are now starting, I'm really excited to announce that we're starting a clinical trial to promote brain health while protecting breast health, and use for hot flashes, menopausal hot flashes. Remember, I know I have to treat at the time that the menopausal hot flash or symptoms are happening, and we will be starting that clinical trial within a matter of weeks. And for anyone who's interested, they can learn more at the Hot Flash Relief, hfrelief.org. And we'll be conducting that here at the CAT Clinic. So many years ago, we made a discovery that is now in phase 2 clinical trial that has the potential of regenerating the Alzheimer's brain, regenerating those areas of the brain that are lost to the disease. And we're very excited about that, and we've actually started that clinical trial. It'll be a multi-site trial across the country, and we'll have a site in Scottsdale shortly. And that's the Regen Brain clinical trial. It's a double-blind, placebo-controlled clinical trial of a molecule, allopregnanolone, or ALLO for short, as a regenerative therapeutic for Alzheimer's disease. The first regenerative therapeutic for Alzheimer's disease, right here from the University of Arizona. And I'm going to skip back this. And this is the website, the Regen Brain website, for those of you who are interested. And lastly, you said you wanted a revolution way back when, and we are delivering on that revolution for vibrant brains that last a lifetime. Thank you. I think we're open for questions. And there's one back there.
Most of what you talked about was for Alzheimer's. What about people who just have mild cognitive loss? Do the same therapeutics and the same type of potential brain repairs, is that along the same line, or is it completely different?
So you're right that it is along a continuum. So mild cognitive impairment can be due to Alzheimer's disease developing. It can be due to other multiple conditions like hypertension, I know cardiovascular disease. So it's important to know what those risk factors are. But if it's due to Alzheimer's disease, what we're really excited about for our regenerative therapeutic is earlier is better, to actually try to promote the regeneration of the brain. So our clinical trial is recruiting individuals in the earliest stages of Alzheimer's disease. Does that answer your question? Mm-hmm. Yes.
Thank you. I was taking atorvastatin for several years, and it was really good in terms of cholesterol reduction. I had a couple stents 6 years ago. I do a lot of exercise and a lot of physical work, but I was having muscle and joint issues. Not great, but probably mild to medium. So I started Repatha the first part of this year, and they pretty much went away. You said the atorvastatin, of the statins there, was the best in terms of mitigation, Alzheimer's disease.
So it's not the best for Alzheimer's disease, right? It's great. I don't want to say it's not great. The reason I like it is because it impacts other systems besides the HMG-CoA system, the cholesterol synthesis system. So, but yeah, there are individuals who will not respond well to one therapeutic while they will to others. And so what happened, as I mentioned, in the subsequent years of developing statins, they became more and more specific. But still, there's about a 50% reduced risk with these statins.
What about the Repatha? That's sort of new on the market the last few years.
My bad. I don't know the actual drug names. I know the kind of chemical names, but...
It's the injectable one. It's,
injectable?
yeah, every 2 weeks.
So it's a long-lasting.
Yeah, and
Yeah.
it reduces even the cholesterol significantly more than the atorvastatin.
Well, I'll have to look into that.
Oh,
Yeah,
okay. Thank
but-
you.
Yeah, but essentially it's quite interesting to me, this consistency across these diseases, that lipid dysregulation, promoting lipid metabolism and cholesterol, synthesis, control, has benefits across diseases you wouldn't necessarily think are related, right? Alzheimer's, ALS, Parkinson's, multiple sclerosis, and yet they do. And what that tells us is that, hold on, there are common drivers to these diseases, and they look different in men and women. Women are at greater risk for developing Alzheimer's and multiple sclerosis. It's not unique to women, but the risk is greater. Whereas in men, the men are at greater risk for developing muscle-related diseases, Parkinson's and ALS, muscle control, Parkinson's and ALS. So I can regale you with some hypotheses about why that is. Yeah.
You mentioned statins and metabolic type 2 diabetes drugs. Is there any time dependency to these? In other words, age dependency?
It's a great question because, for example, hormone therapy, there's a period of time that women and men have an extended timeline for androgen responsivity, but for hormone therapy, it's a specific time window where there can be responsivity. And then that whole system is being changed in the brain, and that's an area that we've been quite focused on, is what happens when this system, how does this system become dismantled? But now on statins and type 2 diabetes therapies, there doesn't appear to be a time limit, right? Because this system, once that system is starting to be dysregulated, it doesn't matter whether one's in their 40s or 70s, the therapies actually are quite effective in regulating that system. Does that make sense?
Yeah, absolutely. Does that mean, I assume it does, the hormones need to be given earlier, but does your phytoserm also have the same characteristics?
Yes, so for phytoserms, they're really targeting that time when the brain is still responsive to estrogen. That system hasn't been dismantled, right? Yeah.
We have a question from an audience member at home. She wanted to know, which breast cancer medications were you speaking of as the ones that activate estrogen in the brain while reducing estrogen in the breasts?
Yeah, so it's a great question. It turns out tamoxifen is great for that. And surprising to us were the aromatase inhibitors, right, that are oftentimes used. And we actually just got a manuscript accepted this morning that goes into great detail on why that is. Now, it turns out that raloxifene is not effective. And the reason is because it doesn't cross the blood-brain barrier well, right? At the clinical dose, it doesn't cross the blood-brain barrier very well, but tamoxifen does, and the aromatase inhibitors do. So exemestane, for example, is one of the aromatase inhibitors.
Thank you.
Okay. But we'll come back to you. Yes, please.
I have a question regarding migraine auras and how they're related to Alzheimer's.
So there is some evidence to suggest that there is a relationship, and I don't know that literature well, but one of the things that may cause migraines is actually hypertension. And that can emerge particularly in women in postmenopause. So I think that's a very important issue to be aware of, is if someone suffers from migraines, are they actually experiencing hypertension?
Thank you.
Mm-hmm. There's a question from, yeah.
You mentioned briefly about prostate cancer medication to be wary or leery of.
Well, you don't
them.
have an option for, go ahead.
Right, but are there, I happen to go see my urologist this Thursday because of elevated PSA, so this obviously is of interest to me. Are you thinking of certain medications specifically that are more problematic?
So the first line therapy for prostate cancer are drugs that inhibit androgen synthesis. Yeah, so that's the key. And so one of the things that I was not aware of until Greg Brannigan started this research in my group, and that is that men who undergo these anti-androgen therapies can experience symptoms that are comparable to menopause. So they can experience hot flashes, they can experience cognitive changes, they can experience mood changes. And that's because these therapies essentially block the ability to synthesize androgens. Now, I can talk to you more about these, unless everybody wants to take the test in, 10 minutes, on these mechanisms of action. Yes.
What was the profile of on your research of the women that you took in? Like
I'm sorry?
age and genetics. Was there something?
Oh, it's a great
genetics?
question. It's a great question. So what we found we did an analysis with our colleagues at USC in Los Angeles to ask the question, could we actually identify women at risk for Alzheimer's disease when they were still healthy, right? And what we discovered was that in a group of women 65 years and older who were all healthy, no one had, a condition that required pharmacological intervention. What we discovered in that group of healthy women was that there were really three groups. Women who were very well metabolically controlled, women who were at the edge, were in that transition state for metabolic syndrome or type 2 diabetes, and another group of women who were in that transition state to cardiovascular disease. And what we discovered is that the cognitive function had significantly declined in women who were at risk for developing type 2 diabetes metabolic syndrome. The women at risk for cardiovascular disease were in the middle relative to women who did not have either of those. And what was very interesting as well is that the women who were driving the cognitive decline in that metabolic, at-risk metabolic group were women who carried the risk factor for Alzheimer's disease, the ApoE4 gene, right? Now, we then went back into the data and we said, hold on, what's the distribution of ApoE4, this risk gene, across all of these women? And it turns out that the distribution wasn't different. So there were as many women in the healthy group, who sustained cognitive function, who were ApoE4 carriers. And what that told us was, hold on, if you are metabolically healthy and have the ApoE4 gene, you're not necessarily going to develop Alzheimer's disease, right, or cognitive decline, right? And that the real factor that can be controlled is metabolic health, right? And that if you maintain metabolic health, you could have the ApoE4 gene and be perfectly fine, right? So to your point, essentially knowing your ApoE genotype, remember, it's a risk factor. It's not an absolute, right? Can give you clues about, hey, you really probably should pay attention, not you, but if you had the ApoE4 gene, pay attention to your metabolic health, to your cardiovascular health. Make certain that things are well controlled. And if you need therapeutic intervention, that you actually get it. Yeah. Is that it? Yes.
You mentioned being able to identify AD early with those who might have some dementia. But are you working towards some kind of blood test? I mean, how it could be simple dementia or, precursor to Alzheimer's.
It's a great question, and we have not worked on the blood test, but blood tests are here, right? Lots of groups in the Alzheimer's field have developed blood tests. So now, it used to be you'd have to have a spinal tap or brain imaging for beta amyloid plaques. Now it's possible for a blood test to be done and to determine whether that blood test for beta amyloid that shows up in your blood or a fragment of the tangles that shows up in your blood, phosphorylated tau, actually now can tell you whether you have the disease or you're, in this kind of transition zone or you're perfectly fine. So there are blood tests, and physicians can now order those tests. Yes.
We're going to go ahead and close off with this last question. It's two related questions from the audience. How long after onset of menopause is it safe to start on hormone replacement therapy? And how long should they take hormone replacement therapy?
So the key here is there sustained menopausal symptoms, right? So just like with puberty, you're going into this transition state and you have lots of experiences during that transition. And then you're done, right? And menopause is the same way, right? So menopausal symptoms are basically the brain telling you, I'm changing, I'm changing, I'm changing, right? And that's your window of opportunity to intervene with hormone therapy. Now, after those symptoms dissipate, the brain is no longer responsive to estrogen. So other interventions might be required. For how long? Our data show that the longer women are on hormone therapy, the better their risk reduction, the greater the risk reduction. Now, when we think about how estrogen works in the brain, estrogen promotes brain health and sustains brain health. It does not reverse brain disease. So it's all about promoting and sustaining brain health. It's not about reversing. And with that, I will thank you. It's been so fun. Thanks so much. I appreciate having the opportunity.
Thank you so much, Dr. Britton. We are very privileged to have had you here tonight. Thank you all for coming, and we look forward to many more lectures and to hearing more from Dr. Britton. Thanks.